This is Higher Maths, it's practice paper D and we're looking at question 6 and this is in the calculator paper. Okay, a manufacturer of executive desks estimates that the weekly cost in pounds of making X desks is given by this expression here. Okay, each executive desk sells for £2,000. Show that the weekly profit made from making X desks is given by this expression here. Okay, so let's start this question off. So part A, and what we'll look at is we'll look at the way of working out the profit. So we should know that profit is going to be equal to the sales minus your costs. So that's the first thing that we're going to set up here. Okay, and let's put it into terms that would be similar to these here. So profit of X desks is equal to the sales. So I know that each desk sells for £2,000, so the sales would be 2,000 times X. I'm going to subtract the costs from that, put it in a bracket, and the cost will be this expression here. So I've got X cubed minus 6X squared plus 560X plus 800. What I'll do is I'll just multiply out by the negative just to gather that all up. That's going to be cubed, that's plus 6x squared, that's minus 560x, and that's minus 800 that's there. What I'll now do is just gather the x terms together and I'll rearrange it into this form here, and that should be my final answer. So I've got minus x cubed, I've got plus 6x squared, I've got 1440. Okay, so that's going to be plus 1440x, and I've got minus 800. So comparing that with that, yeah, I know I've got that right there. That's that part complete. Right, let's go on to part B. How many desks would the manufacturer have to make each week in order to maximise his profit? So this is an optimisation question. It's quite a different type of optimisation question, but let's go ahead and work this one through. Okay. Right. So I know up above that's the weekly profit that's there. So first of all, for part B, let's differentiate. So dp by dx this time. So it's the profit with respect to x, and what we'll go for here is, let's see, it's going to be minus 3x squared plus 12x plus 1440. Okay, and what we'll see here for stationary points, because we'll work out stationary points, it'll be dp by dx equals 0. So what I'll do is I'll substitute a 0 in this side. Make sure you put your zeros in, you must do that. What I'll do is I'll take out a common factor of, let's go for minus 3 as a common factor coming out here. So that'll be x squared, that'll be plus 4x, and that'll be minus, right, that's going to be minus 4x here, minus 4x, and that's going to be minus 480, minus 480 there. Okay, let's go ahead and factorise this part next. So factorising it, putting it into two brackets, or use the quadratic formula for it if that helps you at all. So what we'll have here is x and x and two numbers that multiply together to get 480 with a difference of 4 between them, so that would be, let's go for 20 and 24. The one that's a negative will be this one here, so that's the negative and that one's the positive that's there. So from this part here I've got x plus 20 equals 0, so x equals minus 20. Or x minus 24 equals 0, so x equals 24. And this one here is not a solution. Not a solution because we're not going to make minus 20 desks, we're going to make 24 desks to maximise the profit for this one here. Okay, so what I'll do next is I'll set up a nature table. So let's go for the nature table here. And remember, the nature table is justifying whether it's a maximum or a minimum. I'm going to set this out with an x here. I'm going to have 24 here, I'll have 20 here, I'll go for 20 to the left and 30 to the right. Remember, I'm just wanting to see what this graph would look like as it approaches the 24 and after the 24 as well. Okay, in here, what I'll do is I'll just segregate this a wee bit. So what we'll have here is we'll go for dp by dx. Okay, and what I'm going to be looking at is I'll look at this one here. I'll look at the factorised version. So I've got minus 3, and I've got x plus 20, and I've got x minus 24 in there. So that's the bit that I'm going to consider to work out my values and to work out the shape of the graph. Okay then, so what we have here is if I substitute 24 into this expression here, 24 minus 24 is 0, so 0 times all of that will give me 0. But I already knew that because I set this equal to 0 at the start to work out the 24 that was there. Right, so when I substitute 20 in, so 20 going in here, that would be 40, so 40 and times minus 4 would give me a negative. So it'll give me a negative, that would be times the minus 3 will give me a positive, so that's like a positive, I think that's a positive 480. So that's a positive anyway that's going to be in there, and that's the main thing I'm after. If I substitute 30 into here, so 30 going into this part here, that should work out to be negative, because 30 going in there is positive, so it'll give me 50, and 30 going in there makes that positive, and multiplied by minus 3, that gives me a negative value that's going to go in there. Okay, so the shape of the graph is going to be positive, it's going to be flat, and it's going to be negative. So that there's a maximum at x equals 24. Okay, and that's that part more or less complete. So I'll just state that the manufacturer would have to make and we're going for 24 desks each week to maximise profit. Okay, and that's what we've been asked to do. You know how many desks, so it's 24 desks that it's going to make. So that was B part 1. Let's look at B part 2. Right, what we've got for part 2, we're going to work out the annual profit. Okay, so first of all what I'm going to do is I'm going to work out the weekly profit. Okay, so weekly profit. And what I'm going to use is I'm going to work out what the profit is when we have x as 24. And all I'm going to be doing here is to substitute that into the equation that I've got up here for the profit. So that will be minus, and that will be 24 cubed plus 6 times 24 squared plus 1440 times 24, and then we're going to subtract 800 from that there. So if I fire that just straight into the calculator, then what I should get out there is, see, so it's going to be 233.92. Okay, so that's the weekly profit. But remember what we've been asked to do is to work out the annual profit. And the annual profit is going to be equal to the weekly profit. I'm going to multiply that by 52 weeks. Okay, so that equals 23392 times 52, and again just straight onto the calculator, that will work out to be 1216384. Okay, so that's going to be 1,216,000. Yep, and 384. Yep, that's the marks there. Right, so that's the question complete, and let's see where we're going to get our marks for this question here. So I think what I'll do is I'll take 1 mark for setting up this part here, which would be known that the sales minus the cost equals the profit. Then getting into the form that we've been asked to get it to, so that would be the 2 marks for that one here. 1 mark for differentiating, 1 mark for setting the the differentiated form to 0, so for the stationary points, and making sure your 0 continues down here as well, and then for getting our solutions, the two solutions that come out there. 1 mark for setting up the nature table correctly. Make sure that you annotate it correctly with the x, the values that go in there, and remember that's the differentiated equation that we're working out here. And I'll go for 1 mark for a statement on this one here. On part 2, what we'll go for is 1 mark for getting a weekly profit, and finally 1 mark for getting the annual profit that's there. So that should be out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, isn't it? 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see if I want to give a mark somewhere else. See, yeah, let's take one here for factorising this part out as well. That will give us our 10 marks that appear here. So that's out of 10 marks.